Hello everyone, now we will discuss about DFS. DFS is depth first search. It explores a search tree by going deep as possible into one branch before backtracking to explore the other branches. It's like following one path until you can't go further, then try another. How DFS works means it starts at the root and it goes deep and again backtracks. It keeps repeating until it finds the goal or exhausts all options. Key concept, it follows the leaf for queue, okay, that is last in first out method. Then it is recursive approach. Advantages of DFS is it uses a low memory usage and then useful for certain applications like constraint satisfaction, logical programming, and propositional satisfiability. Disadvantage is it's not completely, it may stuck in infinite loop in cyclic graphs if not careful. Okay, for example, revisiting the same node repeatedly in the loop. It is not optimal. DFS does not guarantee the shortest path or the best path. It may find a solution deep in the tree while missing the shallower goal. Okay, time complexity. DFS has a worst case time complexity of big O of b power m, where m is the maximum depth and b is the branching factor. If the tree is deep or infinite, this can be very large. Now we will see example. Okay, this is the search tree, and then we are starting at the root node. These are the steps. Okay, then we will visit b. Okay, after visiting b, we will visit d. Okay, now after d there is no successor. Okay, for d there is no successor, so we'll backtrack. We'll go back to b. Again we will find there is any successor left over, so e is there. We will visit e. Again for e there is no successor, means child nodes there are not there for e. So again we will go backtrack to a, and then we'll find there is any like successor for a, c. So we will visit c, then e, then again g, like this we will follow. The path is a, b, d, e, c, f, g. Okay, this is the path. Next, one more example we will see. This is the graph they given. This graph is converted into search tree. How means s node, okay, root node, and then for s there are three successors, so a, b, c. Again for a, d, and for b there are two. One is d, another one is d, g. Okay, again for d one more is g, for c, and then g. This is the search tree, and we'll find the path. How means g, let us give g is a goal node. Okay, if we find goal node, we should stop there. Let s be the root node, and from s we will go to a to d, and then d to g. We got the g, so this is the shortest path in DFS. Now we will see DLS. DLS is depth limited search. It is a variation of DFS where we set maximum depth limit. Okay, before doing the searching method, we will set the maximum depth limit to prevent exploring too deep into the infinite or very large space. Okay, to usage of memory and all, we will use DLS. Okay, that is depth limited search. How it works means we will set a depth limit and we will perform DFS. It is also same as DFS, just we will set a depth limit to maximum. After this maximum, you can't explore all those nodes. Okay, key features. Two types of failures it can happen. Failure one is no solution exists in a search tree. Cutoff is no solution was found within the specialized depth limit. DFS is with the limit. Depth first search is a special case of DLS with infinity. Okay, equivalent infinity. Advantage, it handles infinite path and it saves this space. Disadvantage, it is incomplete and non-optimal. We'll see later example. One more is there, that is iterative deepening depth first search, that is IDDFS. It is iterative deepening depth first search. Is a search strategy that combines the benefits of DFS and BFS. Okay, it combines both the strategies of depth first search and the breadth first search. It systematically explores the search space by repeatedly applying DFS, increasing the depth limit with each iteration. How it works means it starts with a depth limit of 0 and perform depth limit search by current depth limit. If a solution not found, increases the depth by limit by 1 and limit, and stop when the goal is found or when no solution exists. Okay, key features like BFS and like DFS. Key features what and all means it is complete and optimal, and it is in DFS use less memories with space complexity of big O of PD. That is B is branching factor and D is depth of the solution. Advantages, low memory usage, no depth limit guessing, handles unknown solution or depth, and it is optimal. Disadvantage, recomputing states. Complexity is big O of b power d, same as BFS. Now we will see example for DLS and then IDDLS. In DLS, before only we will set the limit. Okay, if we set up to level 1, up to level 2 means in level 3 they can't explore the nodes. Okay, up to level 2 only they can explore the nodes. If we set the depth limit, that is L to 2 means up to level 2 only it can explore. First it will go to S and then L, and okay, first they will visit the root node. This is DFS, okay, depth limit search. First level 0, that is S node, and then it goes to A, and then it goes to C. It won't goes to E because the depth limit is set to 2. Okay, then again it goes back to D, again it goes to B, then I, then J. Okay, J is a goal node. We set as J as goal node. If J is not there in level 2, if it is J here means we won't get the solution. That is the disadvantages in DLS. So to overcome this problem, we introduced IDDLS, that is iterative deepening, that first limited search. Same as DLS, it also has a limit, but it will get incremented by step. Like first it will increment the level 0, then if you won't find the goal node, then it will go for next iterative, that is level 2. In level 2 also it won't find the goal node means it will go for next level. Like this IDDFS will work. Okay, in this we will set the limit as L is equals to, we won't set limit in this. The maximum limit of this graph for this is 3. Okay, in first iteration A will visited, then in second iteration up to, in second it will be up to level 1 only. Okay, first it will visit A, B, then C. Okay, in this we won't get the goal node, so again we will iterate one more step, that is up to level 2. In level 2 first it will visit A, then B, then D, after E, then C, then F, then G. Okay, we got the goal node, so we will stop it here. That's all this. Thank you guys. Please do like, share and subscribe.